This conference will now be recorded.
బయట పెట్టాను తీసుకోలేదు పొద్దున్నే పెట్టా తీసుకెళ్ళినట్టున్నారు.
Okay, the first things first. So since I think okay, this is a bit advanced. I think that is this is advanced. Okay, in such case, let's start with basic. Okay. Okay, basically. So I believe yesterday we discussed the basics of Docker, the main origin of what is basically is a Docker or what is called a namespace. Why Docker replaces namespace, right? So can anyone of you can tell me why, what is basically is Docker? Is it a process or is it a virtual machine? Or is it isolated container? Which is basically
it is an isolated container to deploy applications.
You're asking me a question?
No, I'm telling you that it is an isolated container to deploy applications.
No. That way of understanding is really bad. See, Docker, forget about deploying applications or whatsoever. You don't really need to worry about that. And the main word you just said is isolated container. That is exactly the problem, because you are telling the main definition of a Docker, which is it is a container. Okay. No, but container by definition means it's isolated. So you're telling like both in the same sentence, so it's not really fitting together. So let me rephrase that. So imagine this: a Docker is nothing but an isolated process, okay, with the functionality of complete manage. So simple, don't complicate it on that. It's a simple, an isolated process which utilizes namespace, which utilizes Linux namespaces. So yesterday, I believe that was my main focus of showing the article regarding the namespaces. So if you see, the main problem with this particular thing is, if you go to any kind of interview, if that guy is a bit tricky, he gonna play with you with this kind of stuff. That's what I'm trying to have a very firm foundation. The first thing is, what is a namespace? So I believe yesterday we discussed what is a namespace. It's a feature of a Linux which actually provides isolation for a running process. Is that clear? Any doubts in this?
No doubts.
That is clear, right?
Yeah.
It is basically a Linux namespace which provides isolation for running process. That is what basically Docker is built upon. So when you actually create a container, you're not creating a new virtual machine. So if you understand VMs, so if you see, if you observe, you have a hardware, like, which is system, which is your basically your laptop hardware. This is, we are in the layer of infrastructure. Okay. Now, after this infrastructure, if you want to create a virtual machine, so your infrastructure already has what? Your infrastructure already has a kernel. Agreed? Your infrastructure already has a RAM. Your infrastructure already has a processor and all other required hardware with the supporting software which comes as an operating system. Now, if you want to create a virtual machine, you need a hypervisor. What is a hypervisor? VMware is a hypervisor. Zen is a hypervisor. Have you heard about this kind of a technology stack before?
Yes, yes.
VMware. So this is very popular vendor, I think, and he's now also supporting a lot for Docker. So you should be very wary with this particular how this is evolving, because even VMware coming with a new kind of a container stack, but it does has a bit of pluggability towards Docker. But nonetheless, both are competing now. Now, if you see, this is hypervisor. Hypervisor has what? It's a software package, right? So the main utilization of hypervisor is that hypervisor will take an abstraction of your underlying hardware, okay, and creates a virtual map set, okay, which actually helps for the new operating system to run on your infrastructure. So it is something like you can think this is some kind of a let's say pipeline. Okay, here this operating system, okay, will think. So with the hypervisor, you first need to create an operating system. So when you create a first operating system, like I just created by using Vagrant, right? So what happening is that the first operating system thinks it has underlying hardware, but it doesn't. So what it does is that this hypervisor tells that it actually has three infrastructures like this, but instead it has only one, but that is actually hidden by hypervisor. Now the guest always thinks that it is actually running on its own Linux, but in fact, when a request comes from operating system or a process on this system, it actually travels through hypervisor. From hypervisor, it will travel to the real hardware. Okay, so this is the way that actually how the virtual machines work. What is happening here? What's happening here is that you have a kernel already, right? And you have another kernel here. And then you're mapping one kernel actions with another kernel actions. The overhead of a simple request is so high because it has to traverse a path of your guest operating system VM and then connect it to your hypervisor, which in turn get connected to your infrastructure. So one operation will actually have at least 3 invocations. So that's why it is having a lot of overhead. Okay, now let's go to container. You have infrastructure, which is nothing but hardware. Now, instead of, see here the thing is, here the operating system, instead of operating system, you are using some kind of hypervisor. So that is operating system here. But here, I can just install an operating system, any distro. Okay, so that has the Linux, and Linux is communicating with all the hardware components. Now, what sits above it is something called container engine. Okay, a container is, that's the only thing Docker did really efficient. Okay, having building a container engine or a way to maintain containers. Before it was unstable. Now, with the help of container engine, okay, any request, okay, there is no virtual machine here. There is just an engine, that's it. So there is no virtual machine, but there is something called application and required binaries. So application and required binaries communicate with each other and then directly go to the infrastructure. So there is no mapping of a line kernel to a kernel mapping. There's nothing like that. It's very directly going into the infrastructure. Now, that's what I'm trying to tell you. So imagine the amount of workload or overhead has left. So if you take an ideally, if you can create 100 VMs on a hardware infrastructure like a rack, now in this particular application, you can actually go up to 1,000 containers. That is the amount of efficiency this containerization actually helps you to build with. Okay, so this is the main difference between virtualization and containerization. Virtualization is nothing but virtually creating the VMs. Containerization is where you containerize your whole application infrastructure. So this is the main difference between the both. Now I'll let you ask any questions regarding this. Any issues with any doubts?
No doubts.
Richa, you have any doubts on it?
No doubts.
Great. Now, okay. If you see, that is the main core concept of Docker versus container. Now, if you want to work with the Docker containers, the first and foremost thing is to create a new VM. Okay, so let's kickstart that. I think it's already running one, so I have to destroy and recreate it. But it's just for installation, so I don't really mind going with it. So the installation is going on in Ubuntu. Okay. Let's see. Do I have a Docker service or not? Okay. Do I have a Docker installed? No. So let's install Docker. So how do you do installation for a Docker? The first thing you need to do is to go to Docker website. Okay. Go to docs. Go to download and install. Now, this is the Docker. Copy link. It's just index. Okay. Now, Debian. Wait. Do I have a Debian? Ubuntu? Ubuntu is also there. So it's simple. I just need to check the requirements. Okay. The requirements, it works with only these 4 versions for now. So first of all, what I need to do, if I have any previous one, I have to uninstall, but I didn't have them. Now, let's install it. So since it's also a new repository, let's first update. I'm going to install. These are the pre-required packages to actually install the Docker. I'm just saying yes to them. Now I'm adding the Docker file, the k main key to download the Docker file. It is required. Now, check it. I'm updating it. Now I'm installing it. Now I'm checking the installation of Docker. I'm downloading a container from Docker Hub, and it says hello from Docker. Okay. If you don't understand, don't worry about it. It's just that I'm checking it. Now I just need to add Docker into my permissions. Now I'm actually adding my user into Docker group. Now I always no need to add sudo. I have to just type Docker. See, Docker appears. I think I need to source. Can you just solve this? You see? Now no permission is taken. Okay, so that's all about Docker. I hope you followed up. Otherwise, refer this video and try to install Docker on one of your virtual machines. Okay. Now let's dig deeper and venture into Docker English. So you can find the link to install Docker engine. Okay, or follow the demo that I showed to you to install the Docker. Now, before any going further, I think you understand about what is a storage driver. So now you understand that. Okay, think in a technical manner. If you understand that, okay, virtual machines has what disks, which are basically nothing but the host machine hard disk, okay, which uses particular file system as the virtual machine's file system. Now, how does Docker handle storage drivers? Docker a storage driver. First of all, what is a storage driver? A storage driver. So I think if you actually went into device files like the change directory, root, dev, you find a lot of files there. I mean, very few of them actually valid and very few of them will be active. And whatever the dimensions there is basically nothing but kind of a device drivers. So what is a device driver or a storage driver? So basically, driver is actually way of integration with a particular new particular operating system. Now, what is a storage driver? It's an integration or it's a pluggable driver or it's an integration that handles internal storage for containers. So what do you mean by handling again? So you see the currently driver. This particular store with the help of the particular storage driver setting, it is possible to give some internal storage to your Docker container. Since Docker is completely different concept, it's not a VM, but you have to attach some kind of storage to it, otherwise it won't work. How are you going to attach? What is the method? Because you are already using VM in your own operating system. Now you want to use VM on your containers. How can you do that? That can be done via storage driver. So the storage driver basically handles all the internal storages for the containers. Now, if you observe, there would be a default driver for any tech stack. So the default driver for the storage purposes in Ubuntu and CentOS is basically overlay 2. But the device mapper storage driver. So we have another storage driver called as device mapper, and the default one is overlay 2. So the device mapper, which is the latest storage driver, which is the oldest storage driver, will be used in previous versions. So like Ubuntu 11 or 12, you can find that device mapper is there. But for latest one, you can use overlay 2. So if you want to know a bit more information about your storage driver, then you have to use this. Storage. Wow. Should be there. Yeah. So you see, this is your storage driver. Overlay 2. If you want to know more information regarding this, you can actually refer directly in the file. If you overlay 2, it has the file system support ext3fs. So the current Linux file system is of course ext3fs, which currently being used now. So it is also supporting it. Now it supports dtype. These are like some native features of your storage driver. Now, okay, you discussed about what is a device mapper and what is a storage, what is overlay 2, what are these basically actually mean. So the device mapper storage driver is actually used in old ones, okay, but for the newer ones, the complex let's say the demand for extra features is very high. That's why they all together developed overlay 2, and it has been open source project. So now coming to the storage driver, if you want to know more about it, you can also use this particular command, particular file which has this data. The data is there, and it's a get device to, sorry, it's a not device to docker key.json, not key. I have to go inside this directory to check it. Okay, this is docker key. So currently in the latest session we downloaded, I think this is not valid. Now, okay, you know about the most essential component, which is a storage driver. Now let's go into Docker command line. The first and foremost thing that we're gonna check today would be running a hello world container. What is a container? A container is nothing but let's say just having only enough set of files to run the service which is provided by the container. So I want to download a container called hello world, and I want to see what exactly happens in this container. How do you download a hello world container? First of all, where is this hello world container? Why? How can I download using my command line? So Docker Hub, you need to know a bit about Docker Hub here. So if you see, a Docker Hub is basically is kind of a repository, okay, for containers. Just like how you actually source code manage or publish them using GitHub, Docker Hub is actually used for similar purposes, but for Docker. Okay, so I just logged in into my account. So if you see, there are a lot of features in Docker Hub. Basically, we call this as a registry. The registry, so if you don't want to actually go inside the Docker Hub or maintain it, but you want to maintain it, even though you private as well. So Docker Hub is a public, and you also need to buy a subscription if you want to create a lot of repositories or a lot of storages. Okay, but here it is also possible to run a private Docker Hub kind of a registry to actually upload all your artifacts and to run it. So now, what is this Docker? So normally, if you understand, in GitHub, you put all of your source code, right? Similar way, in Docker Hub, you're gonna keep most of the, Docker images or container images. Okay, so let's download the image. So it's a, I believe I already downloaded it. To check it. So Docker images. When you do Docker images, the first and foremost that we actually download is hello world. Okay, so this is a Docker image, but this Docker image actually stores is actually downloaded from Docker Hub. Okay, the first and foremost regarding Docker Hub is to download an image, okay, from Docker Hub. Is that clear?
Yes.
Okay. Why there are only 2 people today? Anyway, so you have just downloaded it, but it is actually not in. It is initiated by you, but this is managed by your command from your command line. Now that is good. Now let's run something called this particular busy box. What is a busy box? A busy box is a very simplistic container with maximum of 1 MB to I think 20 MB in size, which is basically used by DevOps engineer to actually run some commands inside your Docker infrastructure. Okay, so if you want to read more about busy box, you're welcome to read. I can show you a link. You can check it out. So this is the container busy box. So this is basically an open source. It's under GPL license, and you can read a lot about it. You can see what exactly in the documentation. What is BusyBox? It says that hey, it is basically a modem kind of a stuff which actually has all the required settings installed, and you can run a shell script on top. Just give me a second. Now, Docker run BusyBox. What we want to do with this? Do you want to just pull? Or let's okay. What I want to do? Echo hello world. We can do that. Now it's already said the hello world. Now what I want to do is Docker run BusyBox IT bin mesh. So I want to directly go inside the BusyBox and run it. But it's saying that hey, there is some error. Okay, okay, I know why. It's a specific property of a BusyBox. We can move that. We can release Ubuntu, and I think I can turn on latest Ubuntu. So let's check on Ubuntu and Ubuntu. Okay, first let's sign in. Okay, now let's see Ubuntu. This is the repo. Okay, inside the repo you have a lot of references, 18, 19. So these are all distros. So what kind of a distro I want to run right now? I can run 18, I can even run 20. Okay, so let's run 20 then. 20.04. Okay, 20.04. Now it is going to download. Now it is pulling, right? It's downloading. I think I'm giving some kind of I don't know. think I'm doing some mistake. I don't know. 1 second. What did I do? Guys, can you see my screen?
Yes.
Yes.
Oh, sorry. Sorry. Come on, done that. Forward. I got it. I think I know what I did. Okay. I'm sorry, guys. I'm actually using Kubernetes command line. I got confused with Kubernetes and Docker. So we also have something for Kubernetes like IT, again EXE. So I was jumbling here and there. So sorry. So let me just re-explain this. So if you see, let me check the images now. How many images we have? We have a latest, we have the 20.4, we have BusyBox. Now what I can do with the BusyBox is Docker run. I want interactive mode. Hyphen means interactive. T means terminal. That means TTY. That means you're going inside this container now. And you're going to write the container name, BusyBox. Okay. And if you don't write anything after BusyBox, like a colon and mention the version name, then what happened? What is going to happen is that it's gonna actually work with latest tag. Okay. So you have to write a tag. Okay. Currently, I'm writing latest because I have latest. I don't really need to write it, but I can write it. So when I do this, immediately, if you check, I'm in some other space. Can you see? This is not the vagrant machine I have. There's no apt at all. Okay. No, this is container. So currently we are inside the container And a container is just a higher level abstraction of the same structure of a virtual machine, but it is basically an isolated environment which can run or recommended to run only one service. Each container can run one service. One service basically demands one process. So now if you see, currently I'm running a BusyBox. I don't have any app. So if you want to work with or play with BusyBox, you have a lot to learn, because BusyBox is really fun to understand. Okay, so you want to run something, so you don't really need to go inside this particular BusyBox to run it. Instead, you can just use the BusyBox and you can write the command. So let me just tell you. Okay, I'm exiting now. Instead of interactive, by run, I can simply write BusyBox echo hello world and who am I? That's it. You see, the BusyBox is basically a container space, but instead it is actually giving us output of your particular virtual machine. So why does who am I? Who am I becoming a vagrant? So the BusyBox is like a wrapping container. It's a wrapper. Okay, so that's one thing that you need to understand. But imagine if it does the same with the Ubuntu container. Do you think this works? See, Docker PSF. Yeah. But what is the weight of a container? How do you check? For images, weight of a Ubuntu is 73 MB, but weight of a BusyBox is 1 MB. So every time you use Ubuntu, at least 73 MB of your disk space will get used. And the worst part is it's not going to get deleted by default. It's going to stick there, but it's in halted potential. So you have to delete it. How do you going to delete a particular container? We're gonna go with the first of all basic model. So we ran hello world, we ran a BusyBox. Now we are gonna run something called nginx. Okay, docker run nginx.
On Nginx, we host websites, no? HTML.
Yes.
Okay.
Now the container is running, and let me check what is my 192 dot. This is node 1, right? So this should be 11. You see, the nginx is running.
Yeah, yeah.
Okay. Now if I cancel, I'm out of the container. Container is stopped. Oh, this is sorry. This is different. I have to check my hit count. No, this is the right one. Okay, I'm sorry. I think this didn't run, or that's why I use a vanilla machines. Okay, there's no nginx here. Okay, sorry. There is already Apache, that's why. Please on that. Okay, sorry, I know why. Okay, so I ran Nginx, but I didn't give a port. That's why it's not working. So where is my? We're gonna discuss in depth, but let's go with the command line for today. Okay, we have a lot more other commands to look. So let's see. First of all, you run. You understood a command called run. Run actually what run does? It actually runs a container. So running a container means initiating a complete downloadation. If you don't have the container name available, the Docker daemon will actually search for this particular container with the particular name that you've given from Docker Hub, and then the Docker Hub. From there, from the Docker Hub, if the daemon able to find it, it's gonna download the image, and once the image is downloaded, it's gonna kickstart the container. Okay, this is the command utilization of Docker run. Now, when you put some options like just as I shown you, -id, -d, so these all these options are actually has a specific meaning. What is the meaning of -i? Means interactive mode. What is meant by interactive? So you will go inside this container and run them. Okay, but that is not always helpful because when you actually are writing Docker files, you just want some data and you don't want to go inside and do it manually because you are automating stuff. So while automation, this is not really helpful. What really helpful is directly getting this information without logging in. That where you actually utilize DEVOPS. Now, okay, you're running this container, but your container getting stopped whenever the operation if you are inside the container and exit, then by default the container will get stopped. So how do you make sure that your container is actually runs? So you have to start it in a in a mode. We call it actually detached mode, and that is actually mentioned by a command called -d. So you're gonna run with the commands such as docker run -d -d and the name of the container. Only then the container will run in the background. So let me show you a small example. I'm running Nginx. Okay, it's running. Sorry, this is not even good example. Nginx has a different purpose. I am running just Ubuntu. That's it. What is happening? Why I don't see Ubuntu container in my current running list? Docker ps shows the running container list. Now, if you check Docker ps, there's no container. But if you run, the container is running and getting exited. Now, how are you gonna manage this one? Simple. If I just run Docker run -d and then Ubuntu, it's gonna give me a big bunch of sha key. Don't worry about it. But if you use Docker ps and enter, what it should actually show the Ubuntu here. I think Ubuntu is also not the good one to show the only this particular command, but we're gonna experience this sooner or later, so you'll understand. Okay, now you want to name this container. Okay, whatever the container you are running, you want to name the container. So how can I name it? By using a special command called -name and the name of the company, name of the container. Now, if you want to restart a container, then you have to present this particular extension, which is -restart. Okay, restart. So then that Docker will automatically restart the container. You have to understand that by default, there is no restart option. So you can't go inside a container, do some kind of restart just like you do virtual machines. You can't do that. Containers are very different tech stack. So the way they actually interpret and work is also a bit different. So that's why please do understand that if you are running a container in a detached mode, that's going to charge your resources. Okay. So if you are actually running a container in a restart mode, then it is only then it is possible for you to restart the container. Now, until now, we discussed the basic command docker run and then a bit of here and there. Now, let's go a bit further and let's understand how commands which are required to manage docker container. Now, the first and foremost command that you have to understand is docker ps. So what is a ps? It actually lists all the containers which are in a running state. Docker ps, which I used before. Okay, and then docker ps-a is actually list all the containers which are actually in a stop state. Okay, you see docker. Now when I actually mention FNA, it's going to show me all the stopped containers. Now set docker container stop. That means how are you going to stop a container? By using a command called docker container stop and your container ID. This one. If you paste it, it should be name. Otherwise, the name of your container also works. Now, docker container start means that if there is any stopped container, you can start it by using this command. And you have to write docker container start and the name and the particular container ID. Now, docker container RM means remove. So if you want to remove a container, then it's better to use docker container RM on the name of the container. Okay, so this is in short the main command line of Docker. So you have not only understand the basic difference between a Docker and virtual machine today, you also understand how to work with Docker, how to install Docker, and how to run a small, hello world program. Tomorrow we're going to discuss in depth. We're going to discuss Docker images and so on. Okay, so that's all for today. Let me know if you have any questions, guys.
Are we going to do any hands-on projects later on Jenkins and Docker?
I already shown you an hands-on, right? You want to
Okay,
do that? I can give you the Git code. You can actually
okay,
run build it.
okay, yeah, sure. It has README file also with it.
Yes, it does.
Okay, okay, okay.
I mean, it's not that descriptive. It's just very two particular commands, yarn
Okay.
and nothing much. But that should be enough for you to actually build a job. That's
Yeah,
what
sure. I will try that.
I already gave the task for testing. You
Mhm.
could try, but nobody did it, so I stopped giving any tasks.
Okay.
Okay. So okay, guys. Have a great day.
Abdul,
Bye bye. Yeah, Richa.
yeah, how do we set up multiple virtual machine in Vagrant?
Multiple virtual machines in what?
Yes, virtual boxes.
Like this, Richa.
Okay, okay, I'll go through it.
Perfect. Thanks.
Okay, yeah, thank you.